The Copswork 2 project is a marvel of engineering, a pumped storage facility with a powerful 818-meter head and a penstock stretching 1,200 meters, channeled through a massive 3.8-meter diameter pipe. Generating an astounding 614 gigawatt-hours annually, this monumental undertaking began in September 2004 with explosive excavations that tore open 3 access points into the heart of the mountain, setting the stage for a power plant almost entirely underground. At the peak of construction, up to 1,000 miners, builders, technicians, and specialized teams worked tirelessly, day and night, 365 days a year. Water destined for the power plant's turbines is sourced from the Copsey Reservoir, perched at 1,800 meters above sea level. Creating a second inlet into the reservoir demanded that Copsey be temporarily drained, as a colossal tunnel boring machine meticulously carved out a 5.5-kilometer pressure tunnel from Kops to Tafamont. Where this tunnel meets the steep pressure shaft, engineers erected the Tafamont moated structure, a complex network of chambers and shafts engineered to withstand extreme water pressure. The adjoining 1,200-meter pressure shaft plummets nearly vertically, directing water with immense force toward the valley floor. Here, deep within the mountain, lies the core of Copswork 2, a vast machine cavern housing 3 towering 38-meter-high sets of turbines, generators, and pumps. The excavation of this cavern was done exclusively by controlled blasting, each detonation meticulously calculated to advance only a few meters while safeguarding against unintended hazards. The tunnel boring machine itself was a marvel of global engineering. Originally constructed in the US and last employed in China, its nearly 6-meter drill head had to be shipped in 2 halves. A diverse team of international technicians spent weeks reconfiguring and assembling the drill for use in the Versal tunnel, installing precisely positioned precast concrete segments with hydraulic precision. Heavy-duty hydraulic jacks held each segment firmly, while the voids were filled with gravel, later injected with cement. Over 14,000 segments were needed to reinforce the 5.5-kilometer tunnel. Winter work was relentless, with Copsey drained to enable construction of the inlet structure. The tunnel, which will channel water from the reservoir into the Versal tunnel, was first lined with concrete. Before refilling Copsey, 2 monumental throttle valves, each weighing 92 tons and measuring 5 by 5 meters, were carefully installed, Transported over mountain roads from Lower Austria to Montafon, the valves were positioned in an intricate, choreographed procedure, blocking water flow until all was complete. The final piece of this engineering symphony was assembling the pump, a 600-ton mechanism whose largest part, the 7-meter pump spiral, had to squeeze through access tunnels with only millimeters to spare. Anchored with massive bolts, the pump's suction manifold was attached manually. Then, using hydraulic cylinders in place of cranes, the entire structure was shifted into its final position beneath the converter, aligned with hair's breadth precision. At the heart of this energy powerhouse lies the generator, beginning with the stator, the stationary core where the rotor will spin. Transported in halves and assembled on site, the stator was meticulously insulated and tested under high voltage. Its final installation required both 130-ton cranes, as the stator alone weighs 200 tons. Lowered centimeter by centimeter into place, it awaited the arrival of its counterpart, the rotor. Piece by piece, the rotor was assembled, reaching a formidable 240 tons before it too was lowered into the stator, ready to work in unison to convert raw mechanical energy into electricity. Once operational, the rotor spins at 500 revolutions per minute, encased by a dome that prevents water infiltration. With every rotation, this complex machinery transforms the untamed force of mountain water into the electric pulse of modern life. Julius Nyerere Hydropower Station, Tanzania's bold and controversial energy gamble. The Julius Nyerere Hydropower Station, a monumental undertaking by the Tanzanian government, is rising across the mighty Rufiji River in eastern Tanzania. Approved in 2018 amidst heated debate, this project is set to become the fourth largest dam in Africa and the ninth largest in the world. Its construction will reshape the East African power landscape, delivering an estimated 2,115 megawatts with an annual output of 5,920 gigawatt-hour, enough to transform Tanzania's energy capacity. Once completed, it will dwarf other regional power plants and bring Tanzania closer to energy independence. After decades of consideration stretching back to the 1960s, the government finally greenlit the project, placing its management and operation under the state-owned Tanzania Electric Supply Company, TANESCO. Construction began in 2019, with completion anticipated in 2024. This imposing concrete structure will be an arching 134 meters high, holding back a reservoir that spans a staggering 1,200 square kilometers and stores a colossal 34 billion cubic meters of water. A colossal construction effort. The sheer scale of the project is daunting. 4 million cubic meters of earth will be excavated. The 7.5 million cubic meters of aggregate backfill will be laid. 2.6 million cubic meters of concrete will be poured. Reinforced steel will weigh in at 64,000 tons. The primary dam, spanning 1,025 meters along its crest, will rise 130 meters high, built with roller compact concrete for unmatched durability. 4 saddle dams will complement it, ranging from 2.6 kilometers to nearly 8 kilometers in length and up to 21.3 meters in height, designed to contain up to 33 billion cubic meters of water. A sophisticated 400 kilovolt substation and high-capacity transmission lines will connect the dam to Tanzania's public power grid. Additional infrastructure includes 21 kilometers of permanent access roads, 59 kilometers of temporary routes, an integrated administrative complex, and residential accommodations for workers and families. The powerhouse itself is planned to feature 9 vertical Francis turbines, each with a capacity of 235 megawatts, a suite of 9 butterfly valves, and vertical axis generators, cooling systems for both water and sewage, as well as full HVAC, firefighting, and communication setups, extensive control and monitoring systems for comprehensive operational oversight, emergency backup power supplied by 3 diesel generators. Mounting costs and risks, originally estimated at £3.6 billion in a 2013 feasibility study by Odebrecht, the dam's projected costs have been the subject of intense scrutiny. By 2018, rising concrete and construction prices and updated engineering assessments pushed the expected costs to a jaw-dropping $7.57 billion, with projections reaching as high as $9.8 billion when accounting for potential overruns. The Julius Nyerere hydropower station stands as a towering symbol of Tanzania's ambitions, a daring quest for energy independence that teeters on the edge of risk and reward. Environmental and social stakes intensify the project's already fraught landscape, with experts warning that Tanzania's inexperience in large-scale dam construction could invite critical oversights. Missteps in soil management, water disposal, and waste protocols threaten to ripple far downstream, casting doubt on the nation's ability to uphold stringent ecological safeguards. Worker safety looms as a silent specter, given the global track record of dam construction accidents. This monumental project is as much a leap of faith as it is a baptism by fire for Tanzania's developmental dreams, a high-stakes wager where both success and failure will leave an indelible mark. China's monumental mountain-bound hydropower marvel, the Baihetan Project. In the rugged heights of southwest China, where mountains scrape the clouds, the Baihetan Hydropower Project rises as one of humanity's most formidable feats of engineering. This 16-gigawatt behemoth, set along the mighty Jinsha River, a primary tributary of the Yangtze, promises to become the world's second-largest power station, second only to China's Three Gorges Dam. The scope of Baihetan is colossal, spanning across Ningnan County in Sichuan Province and Xiaojia County in Yunnan. Developed by the Jinsha River Chuanyun Hydropower Development Company, a joint endeavor led by the China Three Gorges Corporation, CTG, with stakes from Sichuan and Yunnan energy investment groups, this project is rewriting the future of sustainable power. The project's first two 1 gigawatt turbines roared to life in June 2021, with additional units quickly following, generating a staggering 5 billion kilowatt hours by September 2021. When fully operational, Baihetan's 60 billion kilowatt-hour output will offset around 52 million tons of CO2 annually, marking a transformative impact on China's energy landscape. As one of China's 4 mega hydropower projects exceeding 10 gigawatt, Baihetan stands alongside its monumental counterparts: the 22.5 gigawatt Three Gorges Dam, 13.86 gigawatts Shiluodu, and 10.2 gigawatts Wudongde. Together, these projects form the core of a 46 gigawatt powerhouse within China's ambitious west-to-east power transmission program, channeling the renewable bounty of Western China to meet the soaring energy demands of the East. Baihetan's construction is a saga of innovation. Anchored by a double curvature concrete arch dam towering to 834 meters with a slender crest width of just 13 meters, it holds back a reservoir with a staggering capacity of 20.6 billion cubic meters. With 6 floodgates and 3 spillway tunnels, the structure can release water at an awe-inspiring 42,346 cubic meters per second. The powerhouse complex, set deep within the mountain on each bank of the dam, houses 16 1,000 megawatt Francis turbines, a testament to China's engineering prowess. Collaborating with Dongfang Electric Machinery, CTG pioneered the first 1,000 megawatt hydro turbine generators for this project, a world first in hydropower technology. Components such as turbine stay rings, generator lids, and control rings were crafted by HBIS Wu Steel, while the critical machinery for earthworks was supplied by Caterpillar, contributing to the project's massive scale. This awe-inspiring project, with its unstoppable momentum, is more than a marvel of engineering. It's a towering symbol of China's dedication to renewable energy. As it nears completion, Baihetan is not just an electric powerhouse, but an emblem of the nation's commitment to innovation and a cleaner, greener future.